Good day, friends. Welcome back to Smart Booker. In today's video, we're having another problem on potential difference. Now, one thing here is that in the last video, we discussed the basic concept about potential difference and absolute potential, and we talk a little bit about the formula, right? Now, in this case, we are given the question 2 points, right? A and B are distance at 30 centimeter and 50 centimeter from a 2 micro coulomb charge respectively. What is the potential difference between A and B? Now, the way we can view this, or we can visualize this, is this way. Now we are given a charge Q, which is 2 micro coulomb. We know it is positive, right? Now we first of all have a distance of what? 30 centimeter, and the second one is what? 50 centimeter. And we are told that the point B is the one having 50 centimeter and the point A is the one having what? 30 centimeter, right? So what happened here is that if you look at between this point B and point A, right? Between the point B and point A, we are trying to move a test charge, right? We are trying to move a charge because that's the concept about potential difference. It's just like finding what is the kind of the work done in moving a charge, let's say Q naught, from this B to this point A, in the influence of the electric field which is generated by this charge here, because we know there will always be electric field going out this way, right? So what happened here is that what is the potential difference between these 2 points? Because we can be given any point, so we are given 2 points here. So what we need to do is, how are we going to find the potential difference? We know from our last video that the potential difference between 2 points can be calculated as saying the VAB, which is the potential difference between point B and A, equals Q over 4 pi epsilon naught, right? 1 over RA minus 1 over RB, right? So since that is the case, the potential difference between the 2 points, which is between point B and point A, because you can rewrite this as what? VA minus VB, right? So in that case, this Q over 4 pi epsilon 1 over 4 pi epsilon naught is K, right? So since we know that that is K, and also we are having Q, then open bracket 1 over RA minus 1 over RB. And now we can see that RA is what? 30 centimeter, right? So which means that RA equals to 30 centimeter. We can change it to meter by saying 30 times 10 to the power of -2, which is going to give us a value of 0.3. And RB equals to 50 centimeter. If we convert it to meter, it will be 50 times 10 to the power of -2. That will be equal to 0.5, because you just move it 1, 2. Then you put the point. That's 0.5 meter. Right? Now, we're done with that. What is the charge? What is the value of the charge we are being given? The value of the charge is 2 microcoulomb, right? So Q equals to 2 microcoulomb, which is same thing as 2 times 10 to the power of -6 coulomb, right? So we've write down the what? The given. Now for K, we know K is a constant. K equals to 9 times 10 to the power of 9. All we just need to do is to substitute into the equation, right? So we say that the potential difference between A and B is VAB equals what? Q, right? We'll say K times 10 to the power of 9 times Q, which is 2 times 10 to the power of -6, times 1 over 0.3, which is RA, minus 1 over 0.5, right? So we can simplify this as saying that what? 9 times 2 times 10 to the power of 9 minus 6, 1 over 0.3 minus 1 over 0.5. So we can say this equals to what? 18 times 10 to the power of 3, right? Then 1 over 0.3 minus 1 over 0.5, right? So if we simplify this, we end up having the value 24,000 volts. Definitely VAB is equal to what? 24,000 volts, because the unit of potential difference is volt.